During this lecture, we'll be calculating the frequencies of multiple genotypes that have more than 2 alleles. Now, these are going to be done using the Hardy-Weinberg Law. Well, first of all, let's take a couple of things into consideration before we actually start calculating. First of all, when we're talking about 3 alleles in the scenario that we're going to be taking, at equilibrium, the equation is going to be as follows. P squared plus Q squared plus R squared is equal to 1. Therefore, if we expand this, we're going to get the following. P squared plus 2PQ plus Q squared plus 2PR plus QR is equal to 1. Now, let's just recall that when we were talking about 2 alleles, A and B, we were actually, the equation was as follows. P squared plus Q squared is equal to 1. And the expansion was P squared plus 2PQ plus Q squared. So what I want to mention here is the fact that we are simply expanding, or we are simply adding to this equation. We are not removing anything. Now, using the equation present above, we can easily calculate the frequencies of the genotypes and their alleles. Now, obviously, just like I mentioned before, this is going to be calculating the frequencies of 3 alleles. Now, the example at hand here is the blue mussels, and they have 3 different alleles for the leucine aminopeptidase gene, the LAP. And these are the LAP98, the LAP96, and the LAP94, which are going to be referred to, their frequencies are going to be referred to from now on as P, Q, and R respectively. Well, the frequencies are as follows. The frequency of the LAP98 essentially is going to be 0.52 of the total number of the population. The Q is 0.31 and R is 0.17. Just like we mentioned before, at equilibrium, P plus Q plus R squared is equal to 1. Therefore, P squared plus 2PQ plus Q squared plus 2PR plus 2QR is equal to 1. And this is going to be allowing us to calculate the frequencies. You may ask how we do that. Essentially, let's take the frequency of the LAP98 and for the 2 alleles that are present. All we have to do is using the P squared, which is 0.52 squared. For example, we can take the 2PR example, which is the frequency of the genotypes that have the LAP98 / LAP94 in their alleles, in their genotypes. What is going to the figure we're going to be having here is that to calculate the frequency, which is 2 multiplied by 0.52 times 0.17, and so on and so forth. So this is the gist of it. There's not much to actually dive into even more. Now, it's worth remembering that in order to know the number of the genotypes that we are getting relative to the number of the alleles, we have to use the formula n plus 1 over 2, which in this case we have 3 alleles, so 3 times 3 plus 1 divided by 2, which is going to be 6 different genotypes.